going on today, guys? Today we'll be looking at connection types versus reactions, and we'll do a simple example. So we have about 8 different connection types that will be used in engineering applications or engineering questions. So our first connection type is the external pin, and it has 2 reactions, one horizontal reaction, f of x, and one vertical reaction, f of y. These are the assumed directions, and if you receive a negative value in your analyzation, you have assumed the wrong direction. Alright, the next connection type is an internal pin, which is very similar. It has two forces, Fy and Fx. The Fx is like a normal force, and the Fy is a perpendicular force. Next is the fixed/cantilever support. So this has three different forces. It has a vertical force, a horizontal force, and a moment force. It has a moment force since the cantilever can't be rotated as compared to the external pin, where it can be rotated at the edges. The next connection type is a thrust bearing. It is similar to the fixed pin connection, where it has an Fx and an Fy. Next is the cable support reaction, which has a tension force running along the direction of the cable. And the next one is the roller support, which only supports a vertical force and not a horizontal force. One after is a smooth support, and it only offers a perpendicular force to the surface of which it lies against. And using the Z pattern, we can find that the angle here is theta, which matches the angle of the inclination. And the last connection type is the journal bearing, which is smooth, so it does not resist any horizontal movement. So it will not have a horizontal force, but it does resist vertical movement, so it does have a vertical force, Fy. And for our sample question today, it will be: the shaft is supported by a smooth thrust bearing at B and a journal bearing at C. Determine the resultant internal loading acting on the cross-section at E. So what we want to find is the forces acting at the cross-section at E. We are given 400 pounds of force at A, which is 4 feet away from B, and B is a smooth thrust bearing, so it will only support a vertical, or it will only react with a vertical force. And B is 4 feet away from E, and C is 4 feet away from E, and C is a journal bearing, so much like B, it only offers a vertical force, and D is a vertical force 800 pounds downwards. So our first step in a problem like this would be to find the reaction forces of the supports at B and C. So using our static equilibrium equations, we find that f of x equals 0, and there are no horizontal forces, so we do not need to continue any calculations with that. Next, f of y equals 0. 0 is equal to negative 400 pounds, the force at A, and negative 800 pounds, the force at D, plus the vertical force at B, plus the vertical force at C. B is equal to negative vertical force of C plus 1200 pounds. And if we take our moment equation about B using the right hand coordinate system, the right hand rule, where counterclockwise is positive, We set that equal to 0 since it is static. 0 equals 400 times the distance to B, the perpendicular distance to B, plus the vertical force at C times the horizontal distance minus 800 times 12, the horizontal distance. So we find that Cy equals 1,000 pounds. We sub Cy into 1,000 pounds. We sub Cy equals 1,000 pounds into 1, and we find that By equals 200 pounds. So then we take a method of sections, and we take the right side of it. We can take the left side, and we will get the same answers. So we assume that there are three forces: a shear force, a normal force, and a moment force at E. So using, again, our static equilibrium equations at E, we find Fy equals 0. 0 is equal to the vertical force at E plus 1,000 pounds from Cy minus 800 pounds. The shear force at E equals negative 200 pounds. So we have assumed the wrong direction, and VE is equal to 200 pounds downward. There is no normal force since there is no other horizontal forces. And as for the moment, we take the moment about 0.0, and we consider that E. So the moment is 0 since it is static. 0 equals the negative moment of E, since we assume counterclockwise to be positive, plus 1,000 times the horizontal distance, which is 4, minus 800 times 8, the horizontal distance. So the moment at E equals 2,400 pound-foot, and it is a positive value. So that means we assume the correct direction, which is clockwise. Alright, thank you for watching today.